for being here with us. This is completely strange for us. We are recording at the same time, and this is supposed to be a very interactive session. But don't fear, we're trying to make this as easy as possible as we can. So, welcome to All About Dependencies, Maven Puzzlers, Dependency Resolution Edition. My name is Ixchel Reese.
And I'm Andres Almiray.
So, the name of this session is Maven Puzzlers. So we are super happy to be at the JJOG CCC Fall 2022 conference. This is me. I'm from Mexico. I live in Switzerland. I'm a Java champion. I work for JFrog. I'm part of different open source organizations like the CDF Foundation, the CNCF, the OpenSSF, and I love open source. And I have collaborated in some books.
So I'm Andres Almiray. I'm also a Mexican living in Switzerland, Java champion. I also love a lot of open source. I've been doing this for 16 years or so. It's a while, yeah. And what we like to do is share stories on the things that we have learned across the years. And we would like to share those with you.
Yes. When we were working on these slides, I started imagining our story, remembering our story. We are software developers, and that is our world. Is where we feel the most free. It's what we do in our spare time. It's what keep us going. And the other part is we are all about sharing knowledge. This is my personal motto. I'm a software developer and I'm a human writing code for humans to improve human life. Because even as software developers, we spend more time reading the code of other people than writing our own code. So we read a lot of code. Be kind to the next developer that is going to be reading your code. The other thing that actually drives us is to bring happiness, or at least reduce the annoyance level in the developer life. So for that, we're actually looking for tools that increase the developer happiness. And we have noticed that the tools that are predictable, automatic, reliable, and follow conventions are the ones that make our lives easier. So let's talk about tools. This is the Sneak Java JVM Ecosystem Report of 2021. And the tool for building applications is still Maven. And in the slides, you will start noticing a lot of QR codes. You can actually follow the QR codes to the reports that we are presenting and all the information that is there.
So you can think of Maven as, well, obviously a build tool, but the format, the POM format is used to also consume dependencies regardless of the build tool. This is why we have different bars. If there will only be Maven, then what's the point of showing a bar? There are other build tools, Gradle, Ant, IB, SVT, whatnot, that will use the POM format to resolve dependencies. And this is what the question that was asked to developers. How do you build? But in the end, you still have to know Maven in one way or another, even if you are not using Maven as your main build tool.
You have a phrase that I actually like a lot. You always said, even if you're using, for example, Gradle, because you're importing dependencies from other projects, and these dependencies may be using POMs or BOMs or other things, you're still consuming POMs. So we are still using Maven even indirectly.
If your main build tool is not Maven, happens to be something else, at some point you have to deal with the POM format. So it's a good idea that we understand what's going on with that format in the case of resolving dependencies. And that's what we're going to showcase in this particular session.
Okay, and this is also from the JRevel Java Developer Productivity Report in 2022. And as you can see, the answers are very consistent. 68% of the projects out there, Java projects out there, are using Maven for building. And the last but not the least of the reports is the JetBrains Developer Ecosystem of 2021 for Java. The same picture. So Maven, it's critically important for our Java projects. So let's talk about Maven.
Well, we're going to deal with Maven, obviously.
And jars.
Well, dependencies in Maven or in the Java world are usually packed as jars, but not exactly that kind of jar. It stands for Java Archive.
Yeah, I mean, they are jars, and they are also a lot of them out there. And that's actually something I like to say, that dependencies, you can find them in the Maven repository, for example, Maven Central or any other. But the type of dependencies and our level of dependency is not always the same. So when we are actually dealing with dependencies, this is something I see a lot with developers.
Yeah, we can think Maven is a very trivial XML-based format.
XML.
Right? What's the problem with dependencies? You have a series of coordinates and then you just put them together in a file and you're done, right? But actually, not really. That's kind of the problem. We eventually encounter what is known as the dependency hell, the class path hell, Maven problems. We just want to get done with this thing.
So how do we start, or when we join a new project? Like, you check out the code and they have told you, welcome, this is your new project. What do you do first?
What's your first build command?
Yes, if it's a Maven project, what would be your first Maven command? Yes. I mean, there's a person here, not saying names, that will go into a very, very animated discourse about why shouldn't you use Maven clean install. My advice to you is it works sometimes, the minimal amount of times, but it works. So
but yeah, the problem is that it works most of the times, and that's why people keep using it. But if you're given a choice, I would recommend you to use Maven Verify instead of using Maven clean install all the time. Now the answer lies in the Maven lifecycle. And here is a broad picture of the life cycle. And if you're able to see what's in the top, we had a series of phases going from initialize all the way into deploy.
So as you can see, there are several workflows. I apologize for the image. If you go into this particular blog post, you can see it in bigger. And what Andres is trying to say, it's actually focusing your attention in the upper part, because that is the most well-known Maven workflow. And if you can see, almost at the end of the column, there is verify on top and install second.
Exactly.
So what does that actually mean?
So when you invoke one of these lifecycle phases in Maven, it goes from point A to point B in a sequence. So every time we do install, verify being the phase that is right before that is going to be invoked no matter what. So every time you do install, you're still invoking verify. So if you didn't know that phase existed, it's still there. So install, its only responsibility is to copy the jar files that were created in your build into a Maven local repository.
So verify creates the jars.
A package will create it. Verify, it's kind of like the phase between package and install, and verify is there so that you can hook in something else like running integration test cases, which may be useful in certain projects. But for many people, verify is almost like it will be a no-op. It's just there to be sure that something can be finished. So By just invoking verify all the way your life cycle all the way to verify, you already have all the jars, you have all the artifacts. But we are not polluting your Maven local repository with additional snapshots or additional artifacts that are not needed.
Okay. So verify or install. So most of the time, use verify. So dependency resolution and our graphs can look like this. And well, apologies for the diagram, that was me, and I'm not so good at this. But what I'm trying to say here is that we can have the same dependency with the same version in different parts of our dependency node graph. Now, at different levels, which is important, and we will see how much important.
So as long as it's the same version, doesn't matter where in the graph is, that's not a problem.
It's different versions.
But if we're to be a different version, that's when problems start to arise. And depending on where it is, and in the different levels, that we will see what kind of problems we face.
Okay, as I said before, this is a quiz. So let's move to the quiz part. And for that, we will start with a test. So right now you will see a QR code and some information about Mentimeter. You can join that particular quiz with the QR code or using that link with that code.
So take out your smartphone and scan the QR code and log into the quiz.
Yes, so we will have some questions just to test how this works. So how do you install Maven?
Well, there are many ways to install Maven. Most people know it that they find an URL where they can locate a zip file, download it, unpack it, configure an environmental variable, and then you can able to run the command. But when there is a new version of Maven, what do you do?
Suffer and actually think if you should do that again.
Yes, you do that again and again and again. And what if you already have multiple versions of Maven or you didn't and you need to reinstall and switch? So that's a little bit of a problem. So for that reason, there are package managers. Homebrew is quite popular in Mac. SDKman is our favorite.
Yes,
because it works on all platforms. And the advantage of SDKman is that it's very easy to install any single particular version, but also update or downgrade.
And you can have different versions in different terminals.
At the same time, so multiple versions installed in your system, whereas Homebrew is only one single version per system.
In all your terminals. And actually, that makes a point. And I will only tease this kind of information, but it actually depends the behavior of Maven on the version that you are using because of the super POM. If you're more curious about that, look for this guy's blog post on that.
Okay, next one. So
what is the version of Maven that you're using? And please use it a lot, both, because we really want to have this information.
Right. So when we have run this session before, we have been a bit surprised when people say there's quite a good number of people that say they use a very old version of Maven. It's not even 3.6.3, which is really, really old. It has more than 4 years, if I'm not mistaken. It's close to 3 or 4 years old. Now, the latest version as of today continues to be 3.8.6.
But
if you're not into it, upgrade. If you're using 3.8.5, that has an issue with resolving HTTPS resources. Don't use 3.8.5. That's why it's not even listed here. All right. If you're using a much older version of Maven, try to upgrade as much as possible. But we understand that sometimes it's not possible to do this kind of upgrades.
Okay. So do you use the Maven wrapper?
I guess the other question is, what is the Maven wrapper?
Yes.
What is the Maven wrapper?
It is a way to actually verify or invoke the same version of Maven by executing a specific command.
Yeah, it's kind of like saying this project requires this version of Maven, and there is an additional script that allows you to download that particular version of Maven so that your project can be used. So you, your teammates, CI servers, everybody's going to use the same version.
I mean, it won't try to use the version that you have installed. It will actually pay attention to that and install the version that it's meant to be using. So, do you use the Maven daemon?
So the Maven daemon is yet another tool that we can use. So every time that we invoke any Java tool, we bootstrap a VM, run the tool, and then the VM goes away. And the next time we invoke the tool, once again, the VM, run the tool, and then it dies. So what the daemon does is the first time you bootstrap the VM, that has to happen, you run the tool, and then that VM does not disappear, it goes into the background. So the next time you invoke the same tool, it doesn't bootstrap the VM, it just talks to the VM that is in the background. So that makes your builds faster and faster.
One time, so it's going to be quicker. Maybe consider using it. So those were the actual questions, like the warm-up questions, but then we're going to start with the real ones. And you probably recognize this picture. I won't say anything else, but that's one of my favorites.
That was once our trip to Japan a few years ago. That was the Mario Kart experience.
Yes, yeah, I love it. Well, anyway, let's start. When we say that this actually works, the command that we are invoking is Maven dependency 3.
Yeah, this command is used to verify what is or display the dependency graph.
Okay, so we can start. Let's start with this particular POM file. This is very simple, actually. You can see it says com Google Waba version 27.0, and right after that is Google Waba version 28.
There's basically two definitions of the same dependency with different versions. Now, when we run dependency tree on this POM file, what do we get? Do we get a build error because there are duplicate dependencies? Do we get version 27 because it's defined first? Do we get version 28 because it's defined last? Or do we get version 28 because 28 is bigger than 27? What do you think is going to happen?
You see, there are several tools where the first one wins. There are other tools where the last one wins. Or there are tools that actually pick the latest version. So at this point, I really don't know.
So as it so happens, the primary instinct for many people is to mark these as a build error because duplicate dependencies, that's kind of a problem, right? Well, it turns out this is not a build error. Maven will resolve a dependency for you. It will tell a warning when you attempt to use this POM file, say, oh, hold on a second, this is kind of like a duplicate version, but I will allow it. And by the way, the version that's going to be resolved is
28. I already showed. But this is the point where I want to raise awareness. You have declared the same dependency with different version, and this is not a problem. Like
and a problem is like it doesn't break.
Like this is not a problem. This is a inconsistent. My brain explodes. So let's see what we can do and talk about this particular issue a little bit more. Wait me a second because this is difficult. Okay, so for the people that thought that 28 was the right answer because of semantic versioning,
that's not the case.
Well, I want to say, yes, use semantic versioning, please, 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 please. But this was not the case, and we will see later on why this was not the case. But we want to address first the problem that I said. This is not consistent. Right. This should be a problem.
Maven says warning, but what we want is to turn this into a build error.
Yes, this is crazy.
How can we make this happen? There is an additional plugin that you can configure. It's called the Enforcer plugin. And if there's only a single thing that you learn from this session is configure the Enforcer plugin in your builds. I guarantee you it's going to break your build. And that's what you want. Because most of the times our builds have errors or have these warnings that should be proper errors, and that's how we bubble them up to become real errors. The Enforcer plugin has a series of rules, and here's a list of all the default rules that it has, and the one that we're going to configure is called ban duplicate POM dependency versions.
So by adding this into your POM, then this will happen. Instead of a warning, you will have an error.
Right.
So success. Let's continue because we don't want to spend more time, and we have many questions to continue to ask. So second example. Okay, now with this particular POM file, Andres, tell us what is happening here.
So we have here again two dependencies. We have Google Guava as an explicit dependency or direct dependency. And we have another dependency called truth, which we know has Guava as a transitive dependency. So from the point of view of our POM file name base, we have one hop to go into Guava 28 and one hop to go into truth, but that goes also another hop down into what is Guava version, I think is 31.1 Android, something like that. Okay, so we have
31.1 Android.
We have two versions of Guava somewhere in the graph.
Yes.
When we resolve dependencies, which version of Guava is going to be the chosen one?
Yes. So this is the transient dependencies again. This is important. This is the key part. So the correct answer is 28. Why is this, Andres?
Well, we will said, if Maven were to be aware of semantic versioning, then it should have picked 31.1 Android.
Yes, because it's newer, but it didn't pick that one. It picked 28.
In the previous example, where we had two direct dependencies, the last one won, right? So that was version 28.
Also didn't win.
It didn't win because we were thought that truth being the last one, that's the one that will bring Guava, but it didn't. Again, the reason is because Maven has no clue about semantic versioning, and Maven cares about the position of the dependency in the graph.
So 28 is first. It's
the first that was found, and is the closest.
Okay, so he actually said two things: the closest in the graph. So keep that in mind.
So we go back to the slides to figure out how to make this work.
Wait me a second. Again, this is for. There we go. So, semantic versioning. Yes, please use it. No, maybe is not aware of that.
So this is Robert, who used to be the leader of the Maven project for a while, and he told us back in 2020 that Maven never looks at the version number.
Nope.
It only looks at the position of the dependency in the graph.
Maven started even before semantic versioning was there, so don't ask this tool for something that it was not aware of. But we have good news.
Yeah. So if we use Enforcer again, if we configure a specific rule, like dependency conversions, then we get the following. So now when we run the build, we get these warnings that it also get turned into errors, exactly saying that, hold on a second. So there you have different versions of Guava, but also notice that there are other transitive dependencies that we were not aware of. So that's why the Enforcer is pretty good. And if we use another rule called the require upper bound depth, this is the one that turns in semantic versioning. So when we run the build, now it tells us, look, you have two different versions of Guava.
Make your mind.
Yeah, there's version 27 in this case and 30. Pick one of those.
Okay, so let's continue with the questions. Wait me a second and let's go faster. Yeah. Okay, so new question. Let's make it bigger. So what do we have here? We have, notice, dependency management block. This changes a little bit things. Andres, tell us.
So the dependency management block functions like a lookup table. This is where we define a set of dependencies or gap coordinates. And whenever some of those gap coordinates match, that will be the chosen version. So far it's just dependency management block and truth that we know for a fact is going to bring a version of Guava. So our choices are this is going to fail? Or are we going to get version 27 from dependency management? Or are we going to get version 30 from the transitives?
Remember, Truth has as a transitive version 30, but we have in our dependency management version 27. So the actual answer is 27. Why? Because the dependency management block functions as a catalog, as a reference.
Right, so because there is no explicit version of Guava when we look into our dependencies, so block 23 to 26, we know that Guava is brought transitively, there is no explicit version there. The dependency management block, so no matter where in the graph these Guavas may be, the version that is going to be selected will be 27.
Because that isn't the dependency management block. So remember, dependency management block, it's a reference only for those that are not defined. Okay, let's continue. Next question. Let me make this. Oh.
So in this case, we have again the dependency management block version 27. We have an explicit or direct dependency version 28. And we know we have a transitive dependency 31 on Android. So who is going to win? We only made one change here, which is adding a direct dependency.
So we have then the reference 27, one definition of 28, and the other one that is bringing 30.
So the chosen version is 28 because you might remember something that I said earlier. As long as there is no explicit definition of a version among our dependencies, then whatever in the dependency management block is defined is going to be chosen. But we do have one explicit dependency here, is version 28.
Line 25. So here in line 25 in the dependency block, we said 28. And this is going to win.
Correct.
So
now we bring two dependencies, truth and use, which we know they bring guava as a transitive in one hop. So at the same distance, that's important bit. They are at the same distance. If one of them were to be a different distance, then the one that is shorter will always win.
But this is same distance, both are transient. So we are levering the terrain there. So let's see the actual question.
So we have these two transitive dependencies. We know there's two different versions of guava coming here. The first version is 51 GRE coming from use, and the other version is 31 Android coming from truth. So when we resolve dependencies, who is going to win? Is it going to be 31 GRE because it's defined first? Or is it going to be 31 Android because it's defined latest? Or is it going to be 31 Android because apparently that might be bigger than 31 GRE? I don't know. So
No. Version like that doesn't work. No, you won't fool me again. Okay, let's see. It's going to be a 31 GRE. Why is that?
If you remember the first example, the last dependency won.
Except in transitive dependencies.
Yes, those were direct dependencies. These are transitive dependencies. So the transitive dependencies is the other way around. The first one that is found that is closest wins.
You need to love your tools. You don't need to understand why sometimes. And we love Maven, and this doesn't make a lot of sense, but that is how things are. So the point is, be aware.
There's a set of rules that work for direct, and there's a set of rules that work for transitives.
And they
are inverted.
But such is life. Okay, let's continue.
So we have the same example as before. We have two transitives, but we decided to add now the dependency management block. So we have three potential versions of guava: 28, 31 GRE, or 31 on Android.
So in the dependency management, we have 28. The other things haven't changed. So what is going to happen?
Version 28 wins again.
Why?
Because we don't have explicit dependency to guava,
exactly,
right?
because they are transient. And in the dependency management, I have my reference. So nobody says anything, then we go with my opinion, which is dependency management. So now it's time to talk about parent POMs.
Because so far we have seen a single POM, and that's kind of like easy. But the moment that we start adding hierarchies, and more POMs, then things start to get a little bit tricky.
Okay, so we will have a project POM and a parent POM.
Right, so on the left side, we have the parent, which defines explicit dependency, guava 28. And on the right side, we have a child, depends on that parent, and defines a transitive dependency. Now, when we resolve this, which version is going to be the chosen one? Is it guava 28 from the parent, or is it going to be guava 31 on Android from the child?
Yes.
Or,
so, which one?
I hope that no one chose Bill error, because this still works.
No.
Right, is it version 28? And this, the reason, remember, I shall mention something about the super POM?
Yes.
It's because of how hierarchies work. So when Maven reads your child POM, it starts here. Oh, look, I found a parent
POM.
So I'm going to stop parsing here. I'm going to move into the parent and read the parent. and it reads the whole parent, and they define a parent dependency, a parent definition, nothing like that, okay? So it finish everything, and then what happens?
Goes to the
Maven goes into the super POM. Everybody extends from the super POM. And it reads that, oh, the super POM provides some default plugins, bindings and whatnot, and grabs that and resolves back into the origin. So it grabs what is there in the super POM and resolves something that is known as the effective POM. Then it goes into the parent and says, oh, your parent has defined
a direct dependency. So we have a direct dependency with version 28 at the end. When we stack everything and resolve everything, there is a direct dependency.
Right. In my effective POM right now, I have a direct dependency. And then goes into the child at the beginning of the parsing. And what does he find in the child? As a transitive dependency. So it puts that into the effective POM. Now we have direct and transitive. We have seen this example before. Who wins? The direct dependency will win.
Yeah, so that is actually what happens. Okay, next example. This, we are doing something similar, but notice that on the parent POM, we have a dependency management block. And in the dependency management block, we have 26 as a direct dependency 28, and the transient dependency on the child. So at the end of the day, it's going to be 28. And why is that? Because we have a direct dependencies of 28 in the parent POM.
If you read everything in order, it is as if there's a dependency management block, direct dependency, and transitive dependency. This we have seen so far already. The direct dependency continues to win.
Okay, next example. We have in the child a dependency, transient dependency, and in the parent we only have the dependency management block. And in dependency management block we have 26. So which one is going to win?
It's going to be version 26 because there is no direct dependency. Dependency management block continues to win, and if it is as everything will be in the single effective POM, we have seen this example already, and dependency management block wins.
Yes. Okay. Next example.
In the parent, we have a dependency management block. In the child, we also have a dependency management block.
This is important.
Double dependency management block. And both of them have a guava dependency. Parent has 26 and child has 28.
And the transient dependency. We already know that he's not going to win.
Right. So now the question is first, is it okay to have dependency management in both child and parent?
You cannot prevent it. So it's going to happen. And the one that is going to win is 28. Why is it going to 28? Because the child has the final word.
Right, because when you read everything back in the chain, the first dependency management block from the parent is added to the effective, and then when you read the child, the dependency management block goes there, has the same entries in terms of group and artifact ID, so the child overrides what the parent says, and that's why version 28 wins.
So the child will have more weight on those definitions. Now let's go with a different concept, which is the
BOM file. So we have just 4 more questions to go. A BOM file is a collection of dependencies. It's just like any other POM, but the most important aspect of a BOM POM file is the dependency management block.
So if you don't think that you have found a BOM in your life, you're using already Spring Boot, Quarkus,
Micronaut, JUnit, Jackson.
You are already using it, and you already benefit from it because you usually only introduce one particular entry in your POM, and everything, all the versions of the different, for example, Spring Boot different dependencies are resolved by magic. Well, it's not magic, it's actually this. So let's see the questions.
So on the left side, we have a BOM file that defines BOM, stands for Bills of Materials. It only defines one single entry of Guava. Could be multiple dependencies, but for simplicity, it's just one. And on the right side, we have a consuming POM file, which you notice how we import the BOM. Yes. That's very important.
It's very difficult to a parent POM. Check later on the difference, okay?
And we have 2 transitive dependencies in that consumer. So which is going to be selected? Is going to be the version from the BOM or one of the transitives?
So dependency management on the BOM and 2 transient on the child. Well, on the not child, on the project.
The consumer.
Yes.
So the chosen version is going to be the dependency management block. That's the whole point of importing BOM files. That's what we want.
Exactly. So, okay, next question. We're almost there. We can do this.
So we have a BOM file with a
Dependency management and a dependency block. And the rest is almost the same.
We have a direct dependency in the BOM file, and then we import it. So do we get the version that is 26 coming from the dependency management block? We get 28 that is a direct dependency, or do we get 31100?
28 cannot be because the BOM, when we are working with BOMs, we don't care about the direct dependencies. Just the dependency management works. That's the only thing that matters here.
That's the only important thing about a BOM, is that we make use of the dependency management block. Everything else that is written in the BOM is completely hidden from consumers.
Okay, next one.
We got a BOM, and we have a dependency management block also in the consumer. Notice that we import the BOM, but we also define an explicit dependency to Guava there. So who's going to win?
In the BOM, we have 28, here 26. So who is going to win? It's going to be 26. Why? Even if you import it, think about like writing with pencil. And what you write in your consumer is with pen. Pen wins pencil.
Right, so no matter what we say in the dependency management block when we import it, as long as we have an explicit or a dependency or an explicit version there, is going to win. And that's why.
It doesn't matter if you import it before, after, or something. No. And I like my analogy better. But anyway, so consumer wins. Consumers knows best.
So here we go. We have a dependency management block. We have BOM, and then we import it, and we have a direct dependency and a transitive dependency. So who's going to win? The version from the BOM, the direct, or the transitive?
So at this point, I think you already know it's going to be 28.
Is the direct. That continues to win over no matter what else we do. And that's it.
So this QR code is for you to get into the GitHub repository that this has all these questions with the answers. Look for the different branches. And my last amazing slide, and thank you very much for being here. So I hope you enjoy it. I hope you feel better, that you try to understand better, or you know better Maven. Please, if you are working with different projects, use semantic versioning. For sure, use the Maven Enforcer plugin. It will break your build, but that's the whole point. Check the different building rules that are out there, and I hope you have a very, very bright future. If you want more information, there is another session by Ray Sang, and it is awesome and amazing like he is. So follow that QR code. And this is our final slide. Thank you very much, Andres.
We made it.
Please scan that QR code. If you like the session, this is the best way. Provide us feedback.
This is how we can make things better.
Thank you. Thank you. Thank you very much. I think we're going to be connected and online to see if there are questions or anything, because we have 2 more minutes. So I actually rush you so you can have the last 2 minutes to say whatever you want the audience to take with them.
Once again, you may be using Maven as a main build tool or just as a consumer. We have to know what the POM file is. Make sure to configure the Enforcer plugin, because that's going to make your life much, much easier and in the long run. And if any feedback that you have, or what the things that you found here interesting, or something else, please let us know.
There are many other topics with Maven that we could be touching. So if you have a specific question, let us know. So really fast, Maven verify the different workflows. Check that. Pumps, parent pumps, bump, and super pump. Those are the concepts that we checked here, and the different rules when transient dependencies and direct dependencies. That should be recorded in your brains. Thank you very much, and I hope to see you face-to-face in the next edition of this conference.
Next year.
So